Expression for acceleration in spherical polar coordinates. In the previous video, we have discussed about the velocity in spherical polar coordinates, and in this video, we will discuss how you calculate the acceleration in spherical polar coordinate. From the expression of velocity, we have velocity in spherical polar coordinate r dot e r cap plus r theta dot e theta cap plus r sin theta phi dot e phi cap. Either you write e r cap or r cap. Similarly, you may write theta cap or e theta cap or phi cap or e phi cap. I have discussed it in the video. That is the unit vectors. Unit vector along radial, along the polar, and along the azimuthal. So here you have three components. One is your radial component of velocity, and this is your meridional component of velocity, and this is your azimuthal component of velocity. This is along the radius, radial is along the radius, and this is along the polar, that is the perpendicular plane, and this is the xy plane or along the azimuthal plane. So you have three component of velocity. Similarly, you will have also three component of acceleration. One is your radial acceleration, another one is your meridional acceleration, and the third one is your azimuthal acceleration. So when you calculate the derivative of the velocity with respect to time, you will find the acceleration. So when you calculate the acceleration, so you will have how many components. So when you calculate the derivative of these two, you will have two components. For this you have 3, and for this you have 1, 2, 3, 4. You have to take the partial derivative. So for r dot e r cap, you have r double dot. R double dot means the second derivative of r with respect to time, and you have to keep constant e r cap. Then you have the r dot, then you take the derivative of er cap with respect to time. Similarly, you take the derivative of r with respect to time, that is r dot, then you keep constant theta dot e theta cap, then you keep constant r and e theta cap, and you take the derivative of theta dot, so it will be equal to r theta double dot e theta cap. Similarly, you take the derivative of e theta cap, keeping r theta dot constant. So r theta dot derivative of e theta cap with respect to t. So here you have four derivatives. One is your first, you take the derivative of r, that is r dot, keeping sin theta, phi dot e phi cap constant. Then you take the derivative of sin theta, that is equal to cos theta, theta dot, and derivative of you keep constant phi dot and e phi cap here. Then you take the derivative of phi dot, so it will be equal to phi double dot, keeping r sin theta constant and e phi constant, and you here the fourth one, that is take the derivative of e phi cap, keeping r sin theta phi dot constant. In the previous video, I have explained the value of the unit vector er cap, e theta cap, and e phi cap. This is the values I have calculated, and you have to find out the derivative of er cap, e theta cap, and e phi cap with respect to time. So you first find out the derivative of er cap with respect to t, then derivative of e theta cap with respect to t, then derivative of e phi cap with respect to t, and then you can find out the value of the acceleration. So first you calculate the derivative of er cap with respect to t. So derivative of er cap, this value, derivative of this value, because this is equal to er cap with respect to t. So if you calculate the derivative, of er cap with respect to t, then you will have theta dot e theta cap plus phi dot sin theta e phi cap. Okay, so suppose this is equation number 1, equation number 2, and this is equation number 1, because you have to substitute the value of the derivative of er cap, e phi cap and e theta cap in equation number 1. Now you find out the value of the derivative of e theta cap with respect to t. So if you calculate the derivative of e theta cap with respect to t, that will be equal to minus theta cap er cap plus phi dot cos theta e phi cap. Suppose this is equation number 3. Now you calculate the derivative of e phi cap with respect to t. This is the magnitude of, this is the vector e phi cap. So you calculate the derivative of this, then with respect to t. So this will be your answer. Suppose this is equation number 4. Now substitute the value of equation 2, 3 and 4 in equation 1. If you substitute in equation 1, then you will find the value of the acceleration, this term. Then you rearrange the terms. You multiply the terms in the bracket, and if you rearrange the terms, then you will have this equation. And here you will have a value, that is cos theta er cap plus cos theta e theta cap. And if you solve it, it will be equal to cos phi I cap plus sin phi j cap. I have solved here. If you solve cos theta er cap plus cos theta e theta cap, then you will get cos theta I cap cos phi I cap plus sin phi j cap. You can solve it. So if you put these values and rearrange the term and take common er cap, then e theta cap and e phi cap, then you will have 3 terms. Okay, so this is the expression for the acceleration in spherical polar coordinate. So in acceleration of spherical polar coordinate, you have 3 components of acceleration. One component is your AR component multiplied by ER cap, another A theta component multiplied by E theta cap, another A phi multiplied by E phi cap. This is your radial acceleration. You have to remember it, that is r double dot minus r theta dot square minus r phi dot square sin square theta. This is your radial acceleration, and this acceleration r theta double dot plus 2 r dot theta dot minus r phi dot square sin theta then cos theta. This term is your meridional acceleration, that is across the meridian. This acceleration across the meridian, that is a perpendicular plane. And you will have another acceleration, that is r phi double dot sin theta plus 2 r dot phi dot sin theta plus 2 theta dot phi dot cos theta. This component is your azimuthal acceleration. This is the parallel plane. In the xy plane or parallel plane, this is called the azimuthal acceleration. So you will have 3 components of acceleration. One is your radial acceleration, the second one is your meridional acceleration, this acceleration meridional acceleration, and this acceleration is called your azimuthal acceleration. So you have to remember it. You have to remember these 3 accelerations, and these are the er cap is the unit vector along the radial direction, e theta cap is the unit vector along the polar direction or meridional direction or across the meridian, and this unit vector e phi cap is the unit vector along the azimuthal direction or xy plane or parallel plane. So you have to remember about these 3 accelerations, and In the next video, we will discuss about how you calculate the acceleration in cylindrical coordinate. Thank you.